Pegasus, the winged horse, and the Great Square, a journey through myth, stars, and ancient skies. In the quiet hours of evening, when the sun has surrendered its place to darkness and the first stars begin their nightly vigil, there exists a particular moment of magic. It is that transition between day and night, between the known world beneath our feet and the infinite mysteries suspended above our heads. This is the moment when we might pause, look upward, and find ourselves drawn into stories that have traveled across millennia, carried on the light of distant suns. Tonight, we turn our gaze toward one of the most recognizable patterns in the autumn sky of the Northern Hemisphere, a constellation that has captured human imagination since the earliest days of recorded history. We seek the form of Pegasus, the winged horse of Greek mythology, whose celestial representation has guided sailors, inspired poets, and marked the changing seasons for thousands of years. At the heart of this constellation lies one of the most distinctive asterisms visible from Earth, a perfect square of 4 bright stars that ancient astronomers called the Great Square of Pegasus. But before we climb among the stars themselves, before we trace the outline of wings spread across the darkness, we must first understand where this story begins. Not in the heavens, but in the ancient world, in the minds of people who looked up at the same stars we see tonight and found in their patterns a way to make sense of existence itself. The constellation Pegasus occupies a special place in the northern celestial hemisphere, spanning an area of approximately 665 square degrees, making it the 7th largest constellation in the entire night sky. To find it, one must look toward the autumn months in the northern hemisphere, particularly during the evenings of September, October, and November, when Pegasus reaches its highest point above the southern horizon. The constellation sits in a region of sky sometimes called the celestial sea or water region, surrounded by other constellations with aquatic associations. Pisces the fish, Aquarius the water-bearer, Cetus the sea monster, and Delphinus the dolphin. This placement is no accident, for the myths surrounding these constellations are deeply interconnected, woven together in a tapestry of ancient stories about heroes, monsters, and divine intervention. The Great Square of Pegasus, the distinctive asterism at the constellation's core, consists of 4 stars that form an almost perfect square pattern visible even from light-polluted urban environments. These 4 stars are Markab, Scheat, Algenib, and Alpheratz, though astronomers and historians note that Alpheratz technically belongs to the neighboring constellation Andromeda. Shared between the 2 patterns, in a celestial border that ancient stargazers did not draw with the same precision we use today. This square spans approximately 15 degrees of sky, roughly the width of your fist held at arm's length, making it one of the most recognizable patterns for beginning stargazers and seasoned astronomers alike. The name Pegasus itself comes from the Greek Pegasos, though the etymology of this word remains somewhat mysterious to scholars. Some ancient sources suggested it derived from the Greek word for spring or fountain, pege, connecting the winged horse to his birth from the blood of Medusa near the springs of ocean. Others have proposed connections to earlier languages, perhaps from the ancient civilizations of the Near East, where similar mythological creatures appeared in art and literature long before Greek culture reached its classical height. What we know with certainty is that by the time of the great Alexandrian astronomer Ptolemy, who lived in the 2nd century of the Common Era, Pegasus had already been established as one of the 48 classical constellations, a status it has maintained through all subsequent astronomical catalogues. To truly understand Pegasus, we must journey back to the Bronze Age Mediterranean, to a time when the night sky was not merely a subject of scientific inquiry, but a living text, a book of stories written in light. The ancient Greeks, like many civilizations before and after them, saw the constellations as a form of celestial record-keeping, a way to preserve their most important myths and to mark the passage of time through the year. The appearance and disappearance of certain constellations corresponded to agricultural seasons, to times of planting and harvest, to the safe periods for sailing and the dangerous seasons when storms ravaged the Mediterranean. But the Greeks were not the first to notice these patterns. Archaeological evidence suggests that human beings have been observing and categorizing stars for at least as long as we have been creating art and written language. Cave paintings from the Upper Paleolithic period, more than 17,000 years old, may contain representations of star patterns, though this interpretation remains debated among researchers. What is certain is that by the time of the ancient Mesopotamian civilizations, the Sumerians and Babylonians were keeping detailed astronomical records and had developed sophisticated systems for tracking celestial movements. The Babylonian star catalogues, some dating to the second millennium before the Common Era, contained many constellation patterns that would later be adopted and adapted by Greek astronomers. While the Babylonians did not recognize a winged horse in this particular region of sky, they did observe the stars we now call Pegasus and incorporated them into their own mythological and astronomical frameworks. The transmission of astronomical knowledge from Mesopotamia to Greece occurred gradually through trade routes, military conquests, and the general exchange of ideas that characterized the ancient world. By the time Greek astronomy reached its mature phase in the Hellenistic period, it had absorbed and transformed influences from Babylonian, Egyptian, and other Near Eastern traditions, creating a synthesis that would dominate Western astronomical thought for over 1,000 years. The Greek astronomer Eudoxus of Cnidus, who lived in the 4th century before the Common Era, is often credited with introducing Babylonian astronomical concepts to the Greek world, though he certainly was not the first or only conduit for this knowledge. Eudoxus created one of the earliest comprehensive star catalogues in Greek tradition, describing the constellations and their positions relative to the celestial equator and ecliptic. While his original work has not survived, later astronomers, including the poet Aratus of Soli, drew upon Eudoxus's observations in their own writings. Aratus, writing around the year 270 before the Common Era, composed a long didactic poem called the Phenomena, which described the constellations and their myths in verse form. This poem became immensely popular throughout the ancient world, translated into Latin by figures such as Cicero, and studied by students learning both astronomy and literature. In the Phenomena, Aratus describes Pegasus in vivid terms, noting how the Great Square dominates this region of sky and how the constellation's form suggests a horse emerging from darkness, with only the front portion of the animal visible. As if the creature were rising from some cosmic ocean or fountain. This peculiar feature of the constellation, that it appears to show only the front half of a horse, has intrigued observers throughout history. If you trace the traditional star pattern of Pegasus, you will find the Great Square representing the body, with additional stars extending upward and outward to suggest the neck, head, and mighty wings of the creature. Yet there are no stars to indicate the hindquarters or rear legs. This truncated appearance has led to various interpretations and explanations within Greek mythology, most notably the idea that Pegasus is shown at the moment of his birth, emerging from the blood of the slain Medusa, not yet fully formed, but already possessed of his divine power and speed. Now let us turn to the myth itself, to the story of how this magnificent winged horse came to exist, and what role he played in the grand narratives of Greek heroic legend. The tale of Pegasus cannot be told without also telling the story of Perseus, the hero who slew Medusa, and of Bellerophon, the hero who would later tame and ride the winged horse. These stories interweave, creating a complex narrative that reveals much about ancient Greek values, fears, and understanding of the relationship between mortals and immortals. The story begins with Medusa, one of the 3 Gorgon sisters who dwelt at the edge of the known world, in a place of darkness and terror. The Gorgons were once beautiful maidens, but through the curse of the goddess Athena, Medusa was transformed into a monster so hideous that any living being who looked upon her face would instantly turn to stone. Her hair became a mass of living serpents, her teeth became tusks, her hands turned to bronze, and her eyes acquired the deadly petrifying power. Along with her immortal sisters Estheno and Uriel, Medusa lived in isolation, surrounded by the stone statues of warriors and travelers who had attempted to approach her and had failed. The reasons for Medusa's transformation vary in different ancient sources, revealing the evolving nature of oral tradition and the multiple versions of myths that existed simultaneously in Greek culture. The most common version, preserved by the Roman poet Ovid in his Metamorphoses, suggests that Medusa was a beautiful priestess in Athena's temple who caught the attention of Poseidon, god of the sea. Poseidon, in his desire, violated the sanctity of the temple, and Athena, either unable or unwilling to punish the god directly, transformed Medusa into a monster as punishment. This version of the story has been analyzed extensively by modern scholars as a reflection of ancient attitudes toward assault and blame. But in the context of the ancient myth, it establishes Medusa as both victim and monster, a dual nature that adds tragic depth to the tale. Perseus, son of Zeus and the mortal princess Danae, was sent on a quest to bring back Medusa's head by King Polydectes of Seriphos. The king hoped that Perseus would die in the attempt, clearing the way for Polydectes to force Danae into marriage. But Perseus, as the son of Zeus, had divine favor, and several gods came to his aid. Athena gave him a polished bronze shield, Hermes provided winged sandals and a sharp sword, Hades offered a helm of invisibility, and the nymphs gave him a magical bag to safely carry the severed head. Using the shield as a mirror to avoid looking directly at Medusa, Perseus approached the sleeping Gorgon and struck off her head with a single blow. At the moment of Medusa's death, when her blood spilled upon the earth and merged with the sea foam, two miraculous beings sprang forth from her body. The first was Chrysaor, whose name means golden sword, a giant or warrior who would become the father of other mythological figures. The second was Pegasus, the winged horse, born fully formed and divine, his white coat gleaming, his wings spread wide. The name Pegasus was said to derive from the word for springs or fountains, because he was born near the springs of ocean, at the edge of the world where Medusa dwelt. From his very first moments, Pegasus was a creature of two realms, earthly and celestial, mortal and divine. He was the offspring of Poseidon, who had coupled with Medusa before her transformation, though he emerged from her death rather than through natural birth. This paradoxical origin, a being of beauty and grace born from violence and monstrosity, would characterize Pegasus throughout his mythological journey. After his birth, Pegasus immediately flew away, ascending into the sky with powerful beats of his wings. He flew until he reached Mount Helicon, the sacred mountain of the Muses, those 9 divine sisters who governed all forms of art, poetry, and knowledge. There, according to legend, Pegasus struck his hoof against a rock, and from that spot burst forth the Hippocrene, the fountain of the Muses, whose waters granted poetic inspiration to all who drank from it. This connection between Pegasus and the Muses, between the winged horse and artistic creation, would remain a powerful association throughout classical and later literary tradition. For a time, Pegasus roamed free, belonging to no one, answerable only to his own divine nature. He flew across the mountains and valleys of Greece, occasionally glimpsed by shepherds or travelers who would report seeing a magnificent white horse with wings soaring overhead. These sightings became part of local folklore, and various regions claimed special connections to the winged horse. But Pegasus remained untamed and untamable until one mortal hero proved himself worthy of becoming the horse's master. That hero was Bellerophon, a young prince from Corinth whose name meant either slayer of boleros or bearer of darts, depending on the interpretation of the ancient Greek. Bellerophon's story is one of pride, heroism, and ultimate tragedy, a cautionary tale about the dangers of hubris and the proper relationship between mortals and gods. His connection to Pegasus forms the central chapter of his legend, and it is through Bellerophon's deeds that the winged horse achieved his most famous exploits. Bellerophon's troubles began when he was falsely accused of attempting to seduce the wife of King Proetus of Tiryns. The queen, whose name was either Esthenebia or Antea depending on the source, had actually fallen in love with Bellerophon and made advances toward him, which he honorably rejected. In her anger and humiliation at being refused, she lied to her husband, claiming that Bellerophon had tried to force himself upon her. King Proetus, unwilling to violate the sacred laws of hospitality by killing a guest in his own house, instead sent Bellerophon to his father-in-law, King Iobates of Lycia, with a sealed letter containing instructions to kill the bearer. This motif, sometimes called the Bellerophontic letter, appears in various forms throughout world mythology and literature, always representing a message that condemns the carrier without their knowledge. King Iobates, bound by the same rules of hospitality that constrained Protus, could not directly kill Bellerophon either. Instead, he assigned the young hero a seemingly impossible task: to kill the Chimera, a monstrous creature that was ravaging the Lycian countryside. The Chimera was a composite beast, described by ancient sources as having the head of a lion, the body of a goat, and the tail of a serpent. Some accounts gave it a goat's head emerging from its back, creating a truly nightmare-inducing image of 3 heads and multiple deadly capabilities. It breathed fire, possessed immense strength and ferocity, and had already killed numerous warriors sent against it. King Iobates assumed that Bellerophon would die attempting to fight such a monster, thus fulfilling the instructions in the letter without technically violating hospitality. But Bellerophon received divine guidance, usually attributed to the goddess Athena or to a seer or oracle who directed him to the Paean fountain in Corinth. There, he was told, he would find Pegasus drinking during the night. Bellerophon went to the fountain and waited, and sure enough, the winged horse appeared, descending from the sky to drink from the sacred waters. As Bellerophon watched, the goddess Athena appeared beside him, though some versions say she visited him in a dream the previous night. She gave him a golden bridle, crafted by Hephaestus, the divine smith, and instructed him on how to approach the immortal horse. The taming of Pegasus represents a pivotal moment in both hero's and horse's destiny. Bellerophon did not capture Pegasus through force or trickery, but through a combination of divine favor and proper respect. When he approached the winged horse with the golden bridle, Pegasus allowed himself to be bridled, recognizing in Bellerophon a worthy rider. This moment of mutual acceptance, rather than domination, distinguishes the relationship between Bellerophon and Pegasus from typical stories of horse taming in Greek mythology. They became partners, united in purpose, with each bringing something essential to their shared adventures. Mounted on Pegasus, Bellerophon soared into the sky to face the Chimera. The battle was fierce, but the advantage of aerial attack proved decisive. Flying above the monster, beyond the reach of its claws and fangs, Bellerophon shot arrows down at the beast while Pegasus wheeled and dove with divine grace and power. Some versions of the story say that Bellerophon affixed a lump of lead to the end of his spear and thrust it into the Chimera's mouth. The creature's fiery breath melted the lead, which poured down its throat and solidified, choking it from within. By other accounts, Bellerophon simply wore the monster down with arrows until it collapsed from its wounds. Regardless of the specific details, the outcome was the same. The Chimera was defeated, and Bellerophon returned victorious to King Iobates. Rather than rewarding Bellerophon, however, Iobates sent him on further dangerous missions, still hoping the young hero would die and fulfill the instructions in the sealed letter. Bellerophon, riding Pegasus, defeated the Solymi, a warlike tribe that threatened Lycia's borders. He then vanquished the Amazons, the legendary warrior women, in battle. When Iobates sent his own palace guards to ambush and kill Bellerophon upon his return, the hero defeated them as well. Finally convinced that Bellerophon must have divine protection and favor, Iobates showed him the letter from Protus, revealed the truth of the situation, and gave Bellerophon his daughter in marriage along with half his kingdom. For a time, Bellerophon lived in prosperity and honor. He had proven himself one of the greatest heroes of his generation, comparable to Heracles or Theseus. He had a loyal and supernatural companion in Pegasus, a loving wife, and the respect of his adopted kingdom. But success, as Greek tragedy so often demonstrates, can plant the seeds of downfall. Pride began to grow in Bellerophon's heart, the dangerous pride that the Greeks called hubris, the arrogance that makes mortals forget their proper place in the cosmic order. Bellerophon began to believe that his achievements entitled him to more than mortal rewards. He had ridden the winged horse, defeated monsters, and accomplished tasks that seemed to place him on the level of the gods themselves. In his growing arrogance, Bellerophon decided to ride Pegasus up to Mount Olympus to take his place among the immortals as if he were their equal. This act of supreme presumption could not be tolerated by the gods. Zeus, king of the gods, sent a gadfly to sting Pegasus, and the winged horse reared and bucked, throwing Bellerophon from his back. The fall was catastrophic. Bellerophon plummeted from the heights of heaven back to earth, surviving but terribly injured and broken, both physically and spiritually. The ancient sources vary on the exact nature of his injuries, but most agree that he became lame and blind, or at least severely impaired. He spent the remainder of his life wandering the earth alone, shunned by gods and men alike, consumed by grief and madness. The poet Pindar, in his Olympic ode, speaks of Bellerophon's fate as a warning against mortal pride, emphasizing that no matter how great one's achievements, a human being must remember their limitations and their mortality. Pegasus, freed from his mortal rider, flew onward to Olympus without him. The winged horse was welcomed by the gods, and Zeus gave him a new purpose. Pegasus became the bearer of Zeus's thunderbolts, carrying the divine weapons of lightning and storm across the heavens. In this role, the winged horse transformed from a hero's companion into a symbol of divine power itself, a creature who bridged the gap between earth and heaven, between mortal deeds and immortal forces. It was Zeus who placed Pegasus among the stars, immortalizing the winged horse in the night sky as a constellation. This asterism, the transformation of a mythological figure into a constellation, was a common way for Greek myths to explain the origins and meanings of star patterns. By placing Pegasus in the heavens, Zeus ensured that the story of the winged horse would be remembered for all time, visible to every generation that looked up at the autumn sky. The astronomical reality of Pegasus' constellation contains features that have fascinated observers throughout history. Let us now turn our attention from myth to the stars themselves, to understand what we are actually seeing when we look at this region of the night sky. The Great Square of Pegasus, the distinctive asterism that makes the constellation so recognizable, consists of 4 stars of roughly similar brightness, each with its own fascinating characteristics. Markab, designated Alpha Pegasi in the Bayer system of stellar nomenclature, marks the southwestern corner of the Great Square. This star is located approximately 133 light-years from Earth, meaning that the light we see from Markab tonight began its journey toward us around the year 1892, during the late Victorian era. Markab is a blue-white subgiant star, considerably larger and hotter than our Sun, with a surface temperature of around 10,000 degrees Kelvin compared to the Sun's 5,700 degrees. The star has exhausted the hydrogen fuel in its core and has begun the process of stellar evolution that will eventually transform it into a red giant, and much later, a white dwarf. The name Markab comes from the Arabic word meaning saddle or riding beast, a fitting name for a star in a constellation representing a horse. This Arabic nomenclature reflects the fact that Islamic astronomers of the medieval period preserved and expanded upon Greek astronomical knowledge during the centuries when much of this learning was lost in Europe. The great astronomical treatises of scholars such as Al-Sufi, who worked in the 10th century, catalogued the stars with careful observations and incorporated both Greek constellation patterns and Arabic star names, creating a synthesis that influenced all later European astronomy. Scheat, or Beta Pegasi, marks the northwestern corner of the Great Square. This star is a red giant in the late stages of stellar evolution, and it is noticeably redder than Markab when viewed through binoculars or a telescope. Scheat lies approximately 196 light-years from Earth, and it is a variable star, meaning its brightness changes over time in a somewhat irregular pattern. This variability is caused by pulsations in the star's outer layers, which expand and contract in a slow rhythm, causing the star's apparent brightness to change as we observe it from Earth. The name Scheat likely derives from the Arabic word for leg or shin, indicating this star's position in the traditional Arabic visualization of the constellation. Algenib, or Gamma Pegasi, forms the southeastern corner of the Great Square. This star is another blue-white subgiant, located approximately 390 light-years from Earth, much farther than Markab. Despite this greater distance, Algenib appears nearly as bright as the other stars of the Great Square, because it is intrinsically much more luminous, shining with the light of approximately 5,000 suns. The name Algenib comes from Arabic and means the flank or side, another anatomical reference that reflects how medieval astronomers visualized the constellation structure. The fourth corner of the Great Square, the northeastern star, is Alpheratz, also known as Sura or Delta Pegasi, though it is officially designated Alpha Andromedae, belonging to the neighboring constellation. This dual identity reflects the historical fluidity of constellation boundaries and the shared nature of certain bright stars that seem to belong to multiple patterns simultaneously. Alpheratz is a binary star system consisting of two stars orbiting their common center of mass, located approximately 97 light-years from Earth. The name Alpheratz comes from the Arabic for the horse's navel, while the alternate name Sura means the navel, both referring to its position connecting Pegasus to Andromeda. Beyond the Great Square, the constellation of Pegasus contains many other fascinating stars that trace out the head, neck, and wings of the celestial horse. Inif, or Epsilon Pegasi, represents the horse's nose or muzzle at the end of a chain of stars extending from the Great Square. Inif is an orange supergiant star, one of the most luminous stars visible to the naked eye, located approximately 670 light-years from Earth. If Inif were placed at the center of our solar system, its surface would extend beyond the orbit of Earth, engulfing our planet in its enormous photosphere. This star is nearing the end of its life and will eventually explode as a supernova, though likely not for hundreds of thousands of years. The stars that form Pegasus's wings spread upward and outward from the Great Square, creating graceful curves that require dark skies and imagination to trace. These fainter stars were given less elaborate names in most historical star catalogues, but they play an essential role in completing the constellation's form. When ancient observers looked at these patterns, they saw not just a scattered collection of light points but a coherent figure, a winged horse frozen in mid-flight across the celestial sphere. Modern astronomical observations have revealed that many of the stars in Pegasus host planetary systems, adding another layer of fascination to this ancient constellation. In the year 1995, astronomers Mitchell Mayer and Didier Queloz announced the discovery of the first confirmed exoplanet orbiting a sun-like star. That star was 51 Pegasi, located in the constellation of the Winged Horse. The planet, designated 51 Pegasi b and nicknamed Bellerophon in honor of the mythological hero, was a hot Jupiter, a gas giant planet orbiting very close to its parent star, much closer than Mercury orbits our Sun. This discovery revolutionized our understanding of planetary systems and opened the era of exoplanet astronomy that has now catalogued thousands of worlds orbiting distant stars. The discovery that Pegasus harbored the first known exoplanet seemed almost poetically appropriate to many astronomers and astronomy enthusiasts. Here was a constellation named for a mythological creature that bridged Earth and heaven, and within its boundaries, we found concrete evidence that other worlds existed beyond our solar system, worlds that might harbor their own wonders and mysteries. The connection between ancient myth and modern discovery reminded us that the stars have always inspired both imaginative storytelling and scientific investigation, two complementary ways of exploring the cosmos. The position of Pegasus in the sky makes it a useful navigational aid and seasonal marker. For observers in the northern hemisphere, the appearance of Pegasus high in the southern sky during evening hours signals the arrival of autumn and the approaching winter. The Great Square, with its distinctive geometry, can be used as a reference point to locate other constellations and navigate the autumn sky. Lines extended from the sides of the square point toward other prominent star patterns: Aquarius the water bearer, Pisces the fish, Cygnus the swan, and of course Andromeda, the chained princess whose story is intimately connected with that of Pegasus and Perseus. This brings us to the myth of Andromeda, the second great adventure of Perseus, which occurred after he had slain Medusa and which involved Pegasus in some versions of the tale. Andromeda was the daughter of King Cepheus and Queen Cassiopeia of Ethiopia, a kingdom that ancient Greek geography placed vaguely in the south, though its exact location varied in different sources. Queen Cassiopeia made the fatal mistake of boasting that she, or in some versions her daughter Andromeda, was more beautiful than the Nereids, the 50 sea nymphs who attended Poseidon. This boast angered the Nereids, who complained to Poseidon, and the god of the sea sent a terrible sea monster, Cetus, to ravage the coast of Ethiopia. The monster destroyed ships, devoured fishermen, and brought devastation to the kingdom. King Cepheus consulted an oracle to learn how to end this plague, and the oracle gave a terrible pronouncement. The only way to appease Poseidon and stop the monster was to sacrifice Princess Andromeda to it. She was to be chained to a rock by the seashore, offered to the monster as appeasement for her mother's hubris. Reluctantly, tragically, the king and queen followed the oracle's instructions. Andromeda was chained to a rock at the edge of the sea, left to await her doom as the monster approached through the waves. It was at this desperate moment that Perseus, flying through the air on his return journey from slaying Medusa, happened to pass overhead. Looking down, he saw the beautiful princess chained to the rock, and he saw the terrible monster rising from the sea to devour her. The specific details of how Perseus traveled through the air vary in different versions of the myth. In many classical sources, it is the winged sandals given to him by Hermes that allow him to fly. However, in later versions and artistic representations, particularly from the medieval and Renaissance periods, Perseus is often depicted riding Pegasus during his rescue of Andromeda. This conflation of the two stories, combining elements from Perseus's adventures with Bellerophon's association with the winged horse, demonstrates how myths evolve and blend over time, especially when the constellation patterns in the sky seem to suggest connections between different narratives. Whether flying on winged sandals or mounted on Pegasus, Perseus descended to confront the sea monster. The battle was fierce, with Perseus using the Gorgon's head to turn the monster to stone in some versions, or fighting it with his sword in others. Having rescued Andromeda, Perseus fell in love with the princess and she with him. Despite the fact that Andromeda had been previously promised to her uncle Phineus, Perseus claimed her as his bride, and the two were married. When Phineus and his followers attempted to take Andromeda by force during the wedding feast, Perseus used Medusa's head to turn them all to stone, eliminating this threat to his happiness. The story of Perseus and Andromeda became one of the most popular and frequently depicted myths in classical art and literature. Roman wall paintings, Greek pottery, Renaissance paintings, and Baroque sculptures all return to this dramatic scene of rescue and romance. The constellation patterns in the sky reinforced the story's coherence, with Perseus, Andromeda, Cassiopeia, Cepheus, Cetus, and Pegasus all placed in close proximity, creating a celestial tableau that told the story night after night. For ancient mariners sailing the Mediterranean and beyond, these constellations served practical purposes beyond their mythological significance. The autumn sky, when Pegasus and the Great Square were prominent, marked the end of the safe sailing season. Ancient ships, dependent on oar and sail, vulnerable to storms, typically avoided the open sea during winter months. The appearance of certain constellations signaled when it was time to beach vessels and wait for spring. The Great Square, easily visible even in less than ideal conditions, served as a celestial calendar, a marker of seasonal change that required no instruments or special knowledge to read. The Greek astronomer Ptolemy, working in Alexandria in the 2nd century of the Common Era, compiled his great astronomical treatise the Almagest, which would remain the definitive work on astronomy for over 1,000 years. In this work, Ptolemy catalogued 48 constellations, including Pegasus, providing coordinates and descriptions that allowed astronomers throughout the Mediterranean world and beyond to identify and locate the same star patterns. Ptolemy's work synthesized the astronomical knowledge of earlier Greek astronomers such as Hipparchus, who had worked in the 2nd century before the Common Era, and it incorporated observational data accumulated over centuries. The Almagest represented the culmination of Greek mathematical astronomy, combining geometric models of celestial motion with empirical observations and practical applications. Ptolemy's geocentric model, which placed Earth at the center of the universe with all celestial bodies revolving around it, was sophisticated and mathematically elegant. It could predict the positions of planets, the timing of eclipses, and the movements of stars with impressive accuracy. Although we now know that the Sun, not Earth, is at the center of our solar system, Ptolemy's work represents a remarkable achievement of human observation and reasoning, a testament to what ancient astronomers could accomplish with only their eyes and their minds. When the Western Roman Empire collapsed in the 5th century, much of the accumulated astronomical knowledge of the ancient world was lost in Europe, though it was preserved and expanded upon in the Islamic world. Arab astronomers working in Baghdad, Damascus, Cordoba, and other centers of learning translated Greek astronomical texts into Arabic, added their own observations, and developed new mathematical techniques for calculating celestial positions. The works of astronomers like al-Battani, al-Sufi, and Ibn al-Haytham refined and extended Ptolemaic astronomy, correcting errors, adding newly observed stars, and creating more accurate tables of planetary motion. Al-Sufi's Book of Fixed Stars, completed around the year 964, provided detailed descriptions and drawings of the constellations, including Pegasus. His work included careful magnitude estimates for hundreds of stars, using a scale inherited from the ancient Greeks, and his star catalogue improved upon Ptolemy's in several respects. Al-Sufi also noted the existence of the Andromeda galaxy, visible as a faint smudge of light near the constellation Andromeda, though he described it as a small cloud rather than recognizing it as an entirely separate galaxy. This observation represents one of the earliest recorded sightings of an object beyond our own Milky Way galaxy, though its true nature would not be understood for nearly 1,000 years. During the European Middle Ages, knowledge of astronomy gradually returned to Western Europe through translations of Arabic texts into Latin. The school of translators in Toledo, Spain, working in the 12th and 13th centuries, translated numerous scientific and philosophical works, making Arabic and Greek learning available to European scholars. This transmission of knowledge helped fuel the intellectual revival that characterized the later Middle Ages and the Renaissance, preparing the ground for the scientific revolution that would transform humanity's understanding of the cosmos. The Renaissance brought renewed interest in classical learning, including astronomy and mythology. Artists and writers studied ancient texts with enthusiasm, seeking to recover the wisdom of Greece and Rome. Paintings and sculptures depicted mythological scenes with increasing sophistication and attention to detail. The story of Perseus and Andromeda, the flight of Pegasus, and other classical myths became popular subjects for artistic expression. At the same time, astronomical observation was becoming more rigorous and systematic, leading eventually to the revolutionary discoveries of Copernicus, Galileo, Kepler, and Newton. Nicolaus Copernicus, working in the early 16th century, proposed a heliocentric model of the solar system, with the Sun at the center and Earth as just another planet orbiting around it. This radical proposal challenged both Ptolemaic astronomy and prevailing theological views about humanity's central place in creation. Copernicus's work, published in the year 1543, initiated a transformation in astronomy that would take more than a century to fully develop and gain acceptance. Galileo Galilei, using the newly invented telescope in 1609 and 1610, made observations that provided strong evidence for the Copernican system. He saw mountains and craters on the Moon, proving it was a world similar to Earth rather than a perfect crystalline sphere. He discovered 4 moons orbiting Jupiter, demonstrating that not everything in the cosmos revolved around Earth. He observed phases of Venus, which could only be explained if Venus orbited the Sun, and he saw countless stars invisible to the naked eye, suggesting that the universe was far larger than anyone had previously imagined. Johannes Kepler, using precise observational data collected by Tycho Brahe, determined that planets move in elliptical orbits around the Sun rather than perfect circles, and he discovered mathematical relationships describing planetary motion that we now know as Kepler's laws. These discoveries, published in the early 17th century, provided the foundation for Isaac Newton's later work on universal gravitation and the laws of motion. Newton's Principia Mathematica, published in 1687, demonstrated that the same force that causes an apple to fall from a tree also governs the motions of the moon around Earth and the planets around the sun. This unification of terrestrial and celestial physics represented one of the greatest intellectual achievements in human history, showing that the entire universe operates according to comprehensible mathematical laws. The stars in Pegasus, the motion of planets, the fall of objects on Earth, all were governed by the same fundamental principles. Throughout these revolutionary changes in scientific understanding, the constellations remained constant in the night sky, their patterns unchanged by human discovery. Pegasus continued to wheel across the autumn heavens, the Great Square marking the seasons just as it had for thousands of years. The mythological stories associated with the constellations persisted alongside the new scientific knowledge, demonstrating that narrative and measurement, poetry and mathematics could coexist as complementary ways of engaging with the cosmos. In the 18th and 19th centuries, astronomy entered a new phase with the development of increasingly powerful telescopes and new techniques for analyzing starlight. William Herschel, working in England in the late 18th century, discovered the planet Uranus and conducted systematic surveys of the heavens, cataloguing thousands of stars and nebulae. His sister Caroline Herschel worked alongside him, becoming one of the first women to achieve recognition as an astronomer in her own right, discovering several comets and contributing to the catalogues of celestial objects. The development of spectroscopy in the 19th century allowed astronomers to analyze the light from stars and determine their chemical composition, temperature, and motion. By passing starlight through a prism and studying the resulting spectrum, scientists could identify specific elements present in distant stars, revealing that the universe was made of the same materials as Earth. This discovery profoundly changed our understanding of our place in the cosmos, showing that we are not separate from the universe, but made of the same substance as the stars themselves. The stars of Pegasus, when studied spectroscopically, revealed their individual characteristics. Markab's spectrum showed the signature of a hot blue-white star with strong hydrogen absorption lines. Scheat's spectrum indicated a cool red giant with molecular bands of titanium oxide, a sign of the complex chemistry occurring in its extended atmosphere. Each star told its own story through the language of light, stories written in wavelengths and absorption features that astronomers learned to read with increasing sophistication. Photography revolutionized astronomy in the late 19th and early 20th centuries, allowing astronomers to record the sky with greater accuracy and sensitivity than the human eye could achieve. Long exposures revealed faint stars, nebulae, and galaxies invisible to visual observation. The constellation Pegasus, photographed with sensitive plates and long exposure times, revealed far more than the handful of bright stars visible to the naked eye. Thousands upon thousands of fainter stars appeared, along with distant galaxies scattered throughout the field of view, each one a vast collection of billions of stars separated from us by incomprehensible distances. The 20th century brought the development of quantum mechanics and nuclear physics, which finally explained how stars shine and how they evolve over time. Stars like our Sun generate energy through nuclear fusion in their cores, converting hydrogen into helium and releasing tremendous amounts of energy in the process. This energy gradually makes its way from the core to the surface, then radiates into space as light and heat. The life cycle of a star depends on its mass, with massive stars living fast and dying young in spectacular supernova explosions, while smaller stars like the Sun live for billions of years before gently fading into white dwarfs. The stars of the Great Square we now understand are at different stages in this life cycle. Markab and Algenib, both blue-white subgiants, have exhausted the hydrogen in their cores and have begun to evolve off the main sequence, the stable phase of stellar life that our Sun is currently in. Scheat, the red giant, has progressed further in its evolution, with its core contracting and its outer layers expanding to enormous size as the star nears the end of its life. Alpheratz, the binary system, consists of two stars bound together by gravity, orbiting each other in a cosmic dance that will continue for millions of years. Understanding stellar evolution allows us to estimate the ages of stars and to trace their histories back to their formation in vast clouds of gas and dust. The stars we see in Pegasus were not born together, but formed at different times and places, each following its own evolutionary path. Some may be billions of years old, formed when our galaxy was young. Others may be relatively recent additions to the stellar population, born within the last few 100 million years. The light we see from them tonight left those stars decades or centuries ago, meaning we are literally looking back in time when we observe the night sky. The development of radio astronomy in the mid-20th century opened another window on the universe, allowing astronomers to detect radiation that our eyes cannot see. Radio telescopes revealed new types of celestial objects, including pulsars, quasars, and the cosmic microwave background radiation left over from the Big Bang. The region of sky occupied by Pegasus, when observed at radio wavelengths, shows different features than visible light reveals, with certain stars emitting radio waves and distant galaxies appearing as strong radio sources. Space-based observatories, beginning with the launch of satellites and telescopes above Earth's atmosphere, provided even clearer views of the cosmos. The Hubble Space Telescope, launched in 1990, has observed the Pegasus region at ultraviolet and visible wavelengths with unprecedented clarity. Other space observatories have studied the area in X-rays, gamma rays, and infrared light, each wavelength revealing different aspects of the celestial landscape. The Great Square region contains numerous objects of interest to modern astronomers, including variable stars, binary systems, and distant galaxies, each contributing to our understanding of the universe. The discovery of exoplanets, beginning with 51 Pegasi b in 1995, has fundamentally changed how we think about our place in the universe. We now know that planets are common around other stars, with most stars in our galaxy likely hosting planetary systems. Many of these planets are unlike anything in our solar system, from hot Jupiters orbiting close to their stars to super-Earths with masses between Earth and Neptune. Some of these distant worlds might have conditions suitable for life, though we do not yet have the technology to detect such life if it exists. The search for life beyond Earth has become a major focus of modern astronomy and astrobiology. Scientists are developing techniques to analyze the atmospheres of exoplanets, looking for chemical signatures that might indicate biological activity. Future telescopes and missions may be able to detect oxygen, methane, or other gases that could be produced by living organisms. While we have not yet found definitive evidence of life elsewhere in the universe, the statistical probability that Earth is the only inhabited world among billions of planets seems increasingly small. As we contemplate these modern discoveries, standing beneath the same stars that ancient Greeks and medieval Arabs observed, we find ourselves in a remarkable position. We know vastly more about the physical nature of stars than any previous generation, yet the sense of wonder and mystery remains. The Great Square of Pegasus still inspires awe, even though we understand that it is not truly a square, but a three-dimensional arrangement of stars at vastly different distances, appearing aligned only from our particular vantage point. The mythological stories of Pegasus, Perseus, and Bellerophon remain meaningful even in our scientific age. These stories speak to fundamental human experiences: the desire for freedom and transcendence represented by the winged horse, the danger of excessive pride illustrated by Bellerophon's fall, the heroism of Perseus facing monsters to save the innocent. These narratives continue to resonate because they address aspects of human nature that science alone cannot fully capture. Consider the image of Pegasus flying upward toward Mount Olympus, seeking to reach the realm of the gods. This can be understood as a metaphor for human aspiration, our endless drive to reach beyond current limitations, to explore, to discover, to transcend. Every advance in science and technology represents a kind of flight toward Olympus, an attempt to reach what was previously unreachable. Yet the story also warns about the dangers of hubris, reminding us that there are limits to what mortals should attempt, that wisdom requires recognizing our proper place in the natural order. Bellerophon's fall from Pegasus becomes a powerful symbol of how success and achievement can lead to arrogance and downfall. The hero who defeated the chimera and accomplished impossible tasks ultimately destroyed himself through pride. This theme appears throughout Greek tragedy and mythology, expressing the ancient Greek concept of hubris and nemesis, the idea that excessive pride invites divine retribution. In modern terms, we might interpret this as a warning about the dangers of losing perspective, of believing that personal success exempts us from the constraints and consequences that govern everyone else. The birth of Pegasus from Medusa's blood represents transformation and the emergence of beauty from horror. Medusa, the monster whose gaze turns living beings to stone, gives birth at the moment of her death to a creature of grace and divine power. This paradox suggests that even from violence and tragedy, something magnificent can emerge. It speaks to the complexity of existence, where destruction and creation are intimately linked, where endings and beginnings occur simultaneously. The connection between Pegasus and the Hippocrene fountain, the source of poetic inspiration, establishes the winged horse as a symbol of creativity and artistic achievement. Throughout literary history, Pegasus has represented the flight of imagination, the soaring quality of inspired verse, the connection between the earthly and the transcendent that characterizes great art. Poets from ancient times through the Renaissance and into the modern era have invoked Pegasus as a symbol of their craft, seeking the waters of inspiration that flow from the fountain created by his hoof. When we look up at the constellation Pegasus on an autumn evening, we participate in a tradition that spans millennia. The same patterns that we recognize were seen by Greek sailors navigating the Mediterranean, by Arab astronomers in Baghdad making precise measurements of stellar positions, by Renaissance scholars recovering classical learning, by Enlightenment scientists beginning to understand the physical nature of stars, by modern astronomers discovering planets around distant suns. Each generation has brought its own questions and methods to the study of the stars, yet all have been moved by the beauty and mystery of the night sky. The Great Square serves as an anchor point for navigating the autumn sky. If we extend a line from Scheat through Markab and continue it southward, we arrive at the bright star Fomalhaut in the constellation Piscis Austrinus, the southern fish. Fomalhaut is notable as a relatively nearby star, only about 25 light-years from Earth, which is orbited by at least one planet and is surrounded by a debris disk, the remnants of planetary formation visible in infrared observations. This debris disk, similar to our solar system's Kuiper belt, contains comets, asteroids, and dust, providing clues about how planetary systems form and evolve. If we start at Alpheratz, the corner of the Great Square that belongs to Andromeda, and follow the chain of stars extending from it, we arrive at one of the most remarkable objects visible in the northern sky, the Andromeda Galaxy, also known as Messier 31. This spiral galaxy, similar in structure to our own Milky Way, lies approximately 2.5 million light-years from Earth. On a dark night, far from city lights, the Andromeda Galaxy appears as a faint oval smudge visible to the naked eye. This light, which left the galaxy 2.5 million years ago, began its journey to Earth when our early human ancestors were just beginning to walk upright on the African plains. The Andromeda Galaxy is approaching our Milky Way at a speed of about 110 kilometers per second. In approximately 4.5 billion years, the two galaxies will collide and merge, creating a larger elliptical galaxy in a process that will fundamentally reshape both systems. This collision, though it sounds violent, will likely not result in actual stellar impacts, since the distances between stars within galaxies are so vast that stars will pass by each other like dancers in an elaborate cosmic ballet. However, the gravitational interactions will trigger massive bursts of star formation, reshape the structures of both galaxies, and ultimately blend them into a single unified system. Our Sun and solar system will likely survive this merger, though our location within the resulting galaxy will be different from our current position. Contemplating timescales of billions of years challenges our usual ways of thinking about permanence and change. The constellations we see tonight, patterns that have seemed eternal throughout human history, are actually temporary arrangements. Each star in Pegasus is moving through space at its own velocity, following its own path as it orbits the galactic center. Over tens of thousands of years, these individual motions, called proper motions by astronomers, will gradually change the shapes of the constellations. In 100,000 years, the Great Square will no longer be square. In 1,000,000 years, the constellation Pegasus as we know it will have dissolved into an unrecognizable pattern as the component stars drift to new positions. Yet even as we recognize the impermanence of these patterns, we can appreciate their constancy within the span of human civilization. For all of recorded history, Pegasus has looked essentially the same. The ancient Greek astronomers saw the same great square we see tonight. The pattern that guided medieval sailors is unchanged. This constancy provides a connection across generations, a shared experience that links us to all the humans who have ever looked up at the stars and wondered about their meaning. The mythology of Pegasus reflects deep human concerns about the relationship between mortal and divine, about ambition and limitation, about the nature of heroism and the consequences of pride. These themes remain relevant in our modern world, even though our understanding of the physical universe has been transformed by science. We still grapple with questions about our place in nature, about the appropriate use of power and knowledge, about the balance between striving for greatness and accepting our limitations. The scientific study of the stars has revealed a universe far stranger and more magnificent than ancient peoples could have imagined. We now know that the visible stars are only a tiny fraction of what exists. The universe contains billions of galaxies, each with billions of stars. Most of the matter in the universe is dark matter, a mysterious substance that doesn't emit light, but whose gravitational influence shapes the large-scale structure of the cosmos. Most of the energy in the universe is dark energy, an even more mysterious force causing the expansion of space itself to accelerate. The light we see from distant objects has been traveling for billions of years, allowing us to observe the universe as it was in the distant past. These discoveries have not diminished the wonder of looking at the night sky. If anything, they have enhanced it. Knowing that the light from Markab began its journey in the late 19th century, that the atoms in our bodies were forged in the cores of ancient stars, that we are literally made of stardust, adds depth and meaning to our experience of the cosmos. Science and mythology, rather than being opposed, complement each other as different ways of engaging with the mystery and beauty of existence. The constellation Pegasus reminds us that humans have always been storytellers and pattern seekers. We find shapes in the stars, create narratives to explain what we observe, and use these stories to make sense of our experience. The specific stories may vary across cultures, with different civilizations seeing different patterns and telling different tales, but the impulse to find meaning in the heavens seems universal. The Chinese astronomical tradition, for instance, did not recognize Pegasus as a winged horse, but incorporated these stars into different asterisms within their own system of constellations. The ancient Egyptians, the peoples of Mesopotamia, the indigenous cultures of the Americas, all developed their own ways of organizing and interpreting the night sky. This diversity of interpretation reminds us that constellations are human constructs, patterns imposed on nature rather than existing inherently in the stars themselves. Yet this recognition does not diminish their value or meaning. The stories we tell about the stars, whether ancient myths or modern scientific narratives, are ways of connecting with something larger than ourselves, of participating in mysteries that transcend individual human lives. The practical uses of astronomy have always gone hand in hand with its aesthetic and spiritual dimensions. Ancient peoples needed to track the seasons for agricultural purposes, to navigate during travel, to create calendars for organizing social and religious life. The appearance of Pegasus in the autumn sky signaled the changing season, the approach of winter, the end of the sailing season. These practical applications did not prevent ancient peoples from also finding beauty and meaning in the same celestial patterns. Modern astronomy continues this dual tradition. Astronomers study the stars for scientific knowledge, seeking to understand stellar evolution, galactic structure, cosmology, and the possibility of life elsewhere in the universe. At the same time, astronomy remains one of the sciences most accessible to and most beloved by the general public. Amateur astronomers around the world pursue their hobby with passion and dedication, observing variable stars, tracking asteroids, discovering comets, and simply enjoying the beauty of the night sky. The line between professional and amateur astronomy has often been blurred, with amateurs making significant contributions to scientific knowledge through their observations. The Great Square of Pegasus serves as an excellent starting point for amateur astronomers learning to navigate the night sky. Its distinctive shape is easy to recognize, and once located, it provides a reference for finding other constellations and celestial objects. The process of learning the constellations is one of the first steps in developing a relationship with the night sky, transforming what appears at first as an overwhelming chaos of random light points into an organized and meaningful pattern. This process of learning to see patterns, to organize complexity into comprehensible structures, reflects a fundamental aspect of human cognition. Our brains are evolved to detect patterns, to find order in apparent chaos, to create mental models that help us predict and navigate the world. The constellations represent an ancient application of this cognitive capacity, a way of organizing the vast complexity of the night sky into memorable patterns linked to meaningful stories. In our modern era of light pollution, many people have lost the experience of the truly dark night sky that was familiar to all previous generations of humans. City lights, street lights, and the general illumination of urban and suburban areas create a sky glow that washes out all but the brightest stars. The Great Square of Pegasus, fortunately, is bright enough to remain visible even from moderately light-polluted locations, though the fainter stars that complete the constellation's form may be invisible. For those who have the opportunity to view the sky from a truly dark location, far from artificial lights, the experience can be transformative. The Milky Way becomes visible as a luminous band stretching across the sky, and thousands of stars emerge that are never seen from cities. This loss of the dark night sky represents a real cultural and even spiritual impoverishment. For all of human history until very recently, the stars were a nightly presence in people's lives, a constant reminder of the vastness of the universe and humanity's small place within it. The myths and stories associated with the constellations were living traditions, passed down from generation to generation, connecting people to their cultural heritage and to the natural rhythms of the cosmos. Today, many children grow up never seeing more than a handful of stars, never experiencing the full glory of the night sky. Efforts to preserve dark sky areas and to reduce unnecessary light pollution have become increasingly important for maintaining this connection to the cosmos. The International Dark Sky Association and similar organizations work to promote awareness of light pollution and to preserve areas where the night sky remains pristine. These efforts benefit not only astronomy and human cultural heritage, but also wildlife, since many species depend on natural cycles of light and darkness for navigation, reproduction, and other essential behaviors. The recognition that darkness itself is a natural resource worth preserving represents an important shift in environmental thinking. When we do have the opportunity to observe the night sky from a dark location, the constellation Pegasus reveals far more than just the bright stars of the Great Square. Binoculars or a small telescope show numerous double stars, variable stars, and distant galaxies scattered throughout the constellation. The globular cluster Messier 15, located in Pegasus, is a spherical collection of several 100,000 stars bound together by gravity, orbiting in the halo of our galaxy. This cluster is approximately 33,000 light-years from Earth and about 12 billion years old, formed when the universe itself was less than 2 billion years old. The stars in Messier 15 are ancient, among the oldest objects in our galaxy, survivors from the early era of cosmic history when the first generation of stars was forming galaxies and seeding the universe with heavy elements. Observing such objects reminds us of the immense age of the cosmos. The universe is approximately 13.8 billion years old, born in the Big Bang from a state of extreme density and temperature. In the early universe, only the lightest elements existed: hydrogen, helium, and traces of lithium. All heavier elements, including the carbon, nitrogen, oxygen, iron, and other elements essential for life, were created later in the cores of stars through nuclear fusion. When massive stars exploded as supernova, they scattered these elements into space, enriching the interstellar medium from which new generations of stars and planets would form. Our own Sun and solar system are relatively recent additions to the cosmic story, forming about 4.6 billion years ago from a cloud of gas and dust that contained heavy elements from previous generations of stars. The atoms in our bodies were forged in stellar cores and supernova explosions billions of years ago, making us quite literally children of the stars. This scientific narrative, this story of cosmic evolution from the Big Bang to the present day, rivals any ancient myth in its grandeur and significance. The constellation Pegasus, seen in this context, becomes more than just a pattern of bright stars. It represents a window onto cosmic history, a region of space containing stars at various stages of evolution, ancient globular clusters from the early universe, distant galaxies millions or billions of light years away, and possibly countless planets, some of which might harbor life. Every point of light in this region of sky has its own story, its own history extending back to the formation of the universe. As autumn deepens and winter approaches, the Great Square of Pegasus shifts westward in the evening sky, gradually giving way to the winter constellations that will dominate the cold months ahead. Orion the Hunter, with his distinctive belt and bright stars Betelgeuse and Rigel, rises in the east. Taurus the Bull, with the bright star Aldebaran and the Pleiades star cluster, follows. The brilliant star Sirius, brightest in the night sky, appears low in the southeast. These seasonal changes, the rising and setting of different constellations throughout the year, reflect Earth's motion around the Sun, our annual journey through space that creates the changing appearance of the night sky. The ancient astronomers who first systematically studied these patterns recognized the connection between celestial motions and terrestrial seasons. They understood that the Sun's path against the background stars, the ecliptic, marked the plane of Earth's orbit. They noticed that the Moon and planets also stayed close to the ecliptic, indicating that the solar system has a planar structure. These insights, gained through patient observation over many generations, laid the foundation for all later astronomy. The precession of the equinoxes, a slow wobble in Earth's rotational axis, taking approximately 26,000 years to complete one cycle, gradually shifts the position of the celestial poles and changes the dates when the Sun appears in different constellations. This phenomenon, discovered by the Greek astronomer Hipparchus in the 2nd century before the Common Era, means that the position of the constellations relative to the seasons slowly changes over millennia. In ancient Egyptian times, different stars marked the celestial pole than those we use today. 13,000 years from now, the star Vega in the constellation Lyra will be near the north celestial pole, and the seasons will be associated with different constellations than they are currently. These long-term changes remind us that even patterns which seem eternal on human timescales are actually dynamic and evolving. The universe is not static but constantly changing, with stars being born and dying, galaxies merging and evolving, and the overall structure of space expanding and transforming. Understanding these changes requires thinking in timescales that dwarf human history, yet astronomy has given us the tools to do precisely this, to reconstruct cosmic history from the Big Bang to the present, and to predict the future evolution of the universe billions of years hence. The myths associated with Pegasus speak to more personal and immediate timescales, to individual human lives and the choices we make within them. Bellerophon's story, in particular, offers a meditation on success, pride, and tragedy. Here was a hero who accomplished everything that could be asked of him. He defeated the Chimera, conquered the Solymi and Amazons, won honor and a kingdom. He had everything a Greek hero could desire, yet this was not enough for him. He wanted more, wanted to transcend his mortal nature and join the gods on Olympus. This desire, this refusal to accept limitation, led to his downfall. The story asks us to consider, what are the appropriate limits of human ambition? Should we be content with mortal achievements, or is it noble to strive for more? Greek tragedy often explored this tension, presenting heroes who were destroyed by the very qualities that made them great. The drive to excel, to overcome obstacles, to achieve the impossible, these are admirable traits that lead to great accomplishments. Yet when taken to extremes, when untempered by wisdom and self-knowledge, they become destructive. Bellerophon's fall can be understood as a failure of self-knowledge, a loss of perspective about his place in the cosmic order. He forgot that despite his achievements, he remained mortal, subject to mortality and limitation. The gods, by contrast, are immortal and unchanging, existing on a different plane of being. The attempt to cross this boundary, to claim divine status while still mortal, represents a fundamental category error, a confusion about the nature of reality. Yet we might also read the story more sympathetically, seeing Bellerophon not as simply arrogant, but as tragically reaching for something beyond his grasp, striving for transcendence even knowing it might destroy him. There is something noble in the refusal to accept limitation, even when that refusal leads to tragedy. The human spirit, the story suggests, is characterized by this tension between acceptance and striving, between acknowledging our limitations and struggling against them. Pegasus himself, in contrast to Bellerophon, successfully makes the transition from earth to heaven. The winged horse is welcomed on Olympus, given a place among the gods, transformed into a constellation. The difference lies in nature rather than choice. Pegasus was born divine, offspring of Poseidon, and his ascent to Olympus represents a return to his proper realm rather than an attempted transgression. Bellerophon, born mortal, could never truly belong among the immortals, regardless of his achievements. This distinction raises questions about fate and nature versus achievement and effort. Does what we are born as determine what we can become, or can we transcend our origins through our actions? Greek thought often emphasized the importance of fate and nature, suggesting that certain limitations were simply built into the structure of reality. Yet Greek culture also celebrated heroes who pushed against these boundaries, who achieved extraordinary things despite mortal limitations. This tension between fate and free will, between accepting one's nature and striving to overcome it, runs throughout Greek mythology and philosophy. The transformation of Pegasus into a constellation represents a kind of immortality, a preservation in celestial form that will endure far longer than any mortal life or achievement. The ancient Greeks who created this myth and others, like it, found a way to place their most important stories in the sky, ensuring they would be remembered and retold for as long as humans looked up at the stars. This impulse to create lasting monuments, to find ways of preserving memory and meaning beyond individual lifetimes, appears universal in human cultures. Modern science offers its own form of immortality through discovery and understanding. The astronomers and scientists who have expanded our knowledge of the universe have their names attached to laws, constants, theorems, and celestial objects. Kepler's laws, Newton's constant, the Hubble Space Telescope. These names preserve memory of individual achievement in the permanent record of human knowledge. The discovery of the first exoplanet around 51 Pegasi ensured that Mitchell-Mayer and Didier-Queloz would be remembered as long as astronomy continues as a discipline. Their achievement marked in the sky by the very constellation of the winged horse. As we contemplate the constellation Pegasus on a quiet autumn evening, we participate in multiple levels of meaning simultaneously. We see the physical reality of stars separated by vast distances, each following its own evolutionary path, each with its own planets and possibilities. We recognize the pattern that humans have imposed on these stars, the shape of a winged horse frozen in mid-flight. We recall the myths and stories that have been associated with this pattern for thousands of years, tales of heroes and monsters, pride and tragedy, earthly achievement, and celestial transcendence. All of these layers of meaning coexist without contradiction. The scientific understanding of stellar physics does not erase the mythological significance of Pegasus. The recognition that constellations are arbitrary human constructs does not diminish their cultural and aesthetic value. The ancient myths remain meaningful even though we no longer believe in the literal existence of Zeus and Athena. Each way of engaging with the constellation adds depth and richness to the experience of observing it. The practice of simply looking at the stars, of taking time to observe the night sky, has become increasingly rare in our modern world of constant distraction and artificial light. Yet this practice offers benefits that go beyond astronomical knowledge. There is something deeply calming about stargazing, a way in which observing the vast and ancient cosmos puts daily concerns into perspective. The stars remind us that we are part of something much larger than ourselves, that our individual problems and worries, though real and important to us, occur within a context of immense spatial and temporal scales. This perspective, sometimes called the overview effect when experienced by astronauts viewing Earth from space, can provide a sense of unity and connection that transcends ordinary consciousness. The realization that we are all inhabitants of a small planet orbiting an ordinary star in a galaxy of hundreds of billions of stars, itself just one galaxy among billions in the observable universe, can be simultaneously humbling and exhilarating. It reminds us of our cosmic insignificance, while also highlighting the remarkable fact that the universe has, through us, developed the ability to understand itself. The evolution of life on Earth, from the first simple organisms appearing billions of years ago to the complex ecosystems and intelligent beings of the present day, represents an extraordinary chapter in cosmic history. We are the universe become conscious, matter arranged in such a way as to ponder its own existence and origins. This philosophical perspective, which draws on both scientific knowledge and existential reflection, offers a modern version of the ancient sense of wonder that led people to create myths about the stars. Pegasus, the winged horse born from death and tragedy, ascending to heaven to carry the thunderbolts of Zeus, serves as a powerful symbol for transformation and transcendence. The journey from earth to sky, from mortal to immortal, from limited to unlimited, expresses a deep human longing. We yearn for freedom, for the ability to rise above constraints, for transcendence of our limitations. The image of the winged horse speaks to this yearning more powerfully than any abstract concept could. In practical terms, we now have achieved forms of flight that would have seemed miraculous to ancient peoples. We have built machines that carry us through the air, that allow us to travel between continents in hours, that have taken humans to the moon and sent robotic probes to the edge of the solar system and beyond. The Voyager spacecraft, launched in the 1970s, have left the solar system entirely and are now traveling through interstellar space, carrying messages from Earth to any possible extraterrestrial civilizations they might encounter. These achievements represent a kind of literal fulfillment of the myth of Pegasus, a demonstration that humans can indeed learn to fly, to escape the bounds of Earth and venture into the cosmic ocean. Yet they also demonstrate the difference between myth and reality. Our flight is achieved through technology and engineering, through understanding the laws of physics and building machines that exploit those laws. It is impressive and remarkable, but it lacks the magical quality of a divine winged horse born from a Gorgon's blood. Perhaps this is appropriate. Perhaps the human version of flight, achieved through knowledge and effort rather than divine gift, is more meaningful precisely because we had to work for it, had to understand the principles involved, had to build the technology piece by piece over generations. The Wright brothers' first flight in 1903, lasting only 12 seconds and covering only 120 feet, was nonetheless a genuine accomplishment that opened the door to everything that followed. Each advance in aviation and spaceflight built on previous work, a cumulative process of discovery and invention that continues today. The exploration of space, the study of other planets and moons, and the search for life beyond Earth represent a modern quest narrative, a contemporary version of the heroic journeys undertaken by Perseus and Bellerophon. The astronauts who have traveled to the moon, the scientists studying Mars and the outer planets, the researchers searching for signals from extraterrestrial civilizations, all participate in this grand human adventure of expanding our knowledge and our presence beyond our home world. Yet we must also heed the warning implicit in Bellerophon's story. The exploration of space and the advancement of technology must be undertaken with wisdom and humility, with awareness of potential consequences and limitations. The hubris that destroyed Bellerophon can manifest in modern forms, in technological overconfidence, in exploitation of nature without regard for consequences, in the belief that human power and knowledge have no limits. The environmental crises we face today, from climate change to biodiversity loss, remind us that our actions have consequences and that we must consider carefully how we use our increasing power. The Great Square of Pegasus, that simple geometric pattern of 4 bright stars, contains all these layers of meaning. It is simultaneously a navigational aid, a seasonal marker, a mythological symbol, a scientific object of study, and a source of aesthetic pleasure and philosophical reflection. When we look at it, we can choose to engage at any or all of these levels, finding in it whatever meaning speaks most powerfully to our current needs and interests. For someone learning astronomy, the Great Square provides an easy-to-find landmark for orienting themselves in the night sky, a first step in the journey toward becoming familiar with the constellations and their patterns. For a historian, it represents a connection to ancient civilizations and their ways of understanding the cosmos. For a scientist, it offers objects of study that can reveal the workings of stellar evolution, galactic structure, and cosmic history. For a poet or artist, it provides inspiration, a source of imagery and metaphor. For someone simply seeking peace and perspective, it offers a point of focus for contemplation, a reminder of the vastness and beauty of the universe. As night deepens and the stars wheel overhead in their ancient patterns, as Pegasus gradually moves toward the western horizon where it will set in the hours before dawn, we can reflect on the journey we have taken through myth and history, science and philosophy. We have traced the story of the winged horse from his miraculous birth to his celestial immortalization. We have followed Perseus in his quest to slay Medusa and Bellerophon in his triumph and tragedy. We have explored how ancient peoples understood these stars and how modern astronomy has revealed their true nature. We have considered the enduring human fascination with flight and transcendence, the tensions between mortal limitation and divine aspiration. The constellation Pegasus will continue its nightly journey across the sky long after we are gone, remaining essentially unchanged for many millennia to come. Future generations will look at the same pattern we see tonight, though they may tell different stories about it or understand its stars in ways we cannot yet imagine. The advancement of knowledge continues, with new discoveries constantly adding to and sometimes revising our understanding of the cosmos. Instruments and techniques not yet invented will reveal aspects of the universe we cannot currently perceive, yet certain fundamental experiences remain constant. The simple act of looking up at the night sky connects us to all humans throughout history who have done the same. The wonder and curiosity inspired by the stars transcends cultural and temporal boundaries. The questions we ask about our place in the universe, about meaning and purpose, about the nature of existence, are the same questions humans have always asked, even if the answers we propose may differ. In this sense, the mythology of Pegasus and the scientific study of the constellation are not opposed but complementary. Both represent human attempts to engage meaningfully with the cosmos, to find patterns and meanings in what we observe, to connect ourselves to something larger than our individual lives. The ancient Greeks who created the myth of the winged horse and the modern astronomers who study exoplanets around 51 Pegasi are engaged in the same fundamental human activity, the quest to understand our place in the universe and to find meaning in the vastness that surrounds us. The seasonal appearance of Pegasus, rising in the eastern sky during late summer evenings and reaching its highest point in autumn, has marked the passage of time for countless generations. Agricultural societies timed their harvests and preparations for winter by the positions of the stars. Sailors knew that when Pegasus dominated the southern sky, the sailing season was ending and storms would soon make the Mediterranean dangerous. This practical knowledge, accumulated over centuries of observation, was encoded in the very structure of mythological stories, which served as mnemonic devices for remembering important seasonal markers. The Greek poet Hesiod, working around 700 years before the Common Era, wrote the Works and Days, a didactic poem providing agricultural advice tied to astronomical observations. He instructed farmers when to plow, when to harvest, when to prune vines, all based on the rising and setting of particular stars and constellations. This integration of astronomy into daily life reflected a worldview in which the heavens and earth were intimately connected, where celestial patterns governed terrestrial events, where the gods who dwelt on Olympus also influenced human affairs. This worldview has largely been replaced in modern times by a more mechanistic understanding of nature, where the movements of celestial bodies are governed by gravity and inertia rather than divine will, where weather patterns follow physical laws rather than reflecting the moods of gods, where the success of crops depends on soil chemistry, water, and climate rather than celestial favor. Yet something may have been lost in this transition, a sense of connection and meaning that the ancient worldview provided. The philosopher and cultural critic Max Weber described the modern condition as one of disenchantment, suggesting that the scientific worldview, for all its explanatory power and practical benefits, has stripped the world of magic and meaning. The stars are no longer divine beings or manifestations of cosmic will, but simply masses of incandescent gas following predictable physical laws. The universe operates mechanically, without purpose or intention. We find ourselves in a cosmos that seems indifferent to human concerns, where meaning must be created by conscious beings rather than being inherent in the structure of reality itself. Yet this assessment may be too pessimistic. The scientific understanding of the cosmos reveals a universe far more vast, complex, and ancient than the mythological worldview imagined. The story told by modern cosmology of a universe born in the Big Bang, evolving over billions of years, giving rise to galaxies and stars and planets and ultimately to life and consciousness, has its own grandeur and beauty. The realization that we are made of stardust, that the atoms in our bodies were forged in stellar cores, creates a connection between ourselves and the cosmos that is literal rather than merely metaphorical. The physicist Carl Sagan eloquently expressed this perspective, describing humans as a way for the cosmos to know itself. Through us, through human consciousness and scientific investigation, the universe has developed the capacity for self-reflection and understanding. This is extraordinary when considered carefully. For billions of years, the universe evolved unconsciously, following physical laws without awareness or purpose. Then, on at least one planet orbiting one star in one galaxy, conditions allowed life to emerge and eventually evolve into conscious, intelligent beings capable of studying their own origins and the nature of reality. Whether this has happened elsewhere in the universe remains unknown. The search for extraterrestrial intelligence continues, with radio telescopes listening for signals from other civilizations, and with scientists developing methods to detect biosignatures in the atmospheres of distant planets. The discovery of life elsewhere, especially intelligent life, would profoundly impact our understanding of our place in the cosmos. It would demonstrate that the emergence of life and intelligence is not a unique accident, but a general feature of the universe, perhaps even an inevitable outcome given the right conditions. The constellation Pegasus, with its numerous stars potentially hosting planetary systems, could conceivably harbor worlds where other beings look up at their own night sky and wonder about the nature of existence. Those beings would see entirely different constellations from their vantage point, would have created their own myths and stories to explain what they observe, would have developed their own sciences to understand the physical reality underlying appearances. The thought that somewhere among those thousands of stars, on a planet we cannot yet detect, consciousness might be contemplating similar questions we face is both humbling and exhilarating. The Fermi paradox, named after physicist Enrico Fermi, asks why, if intelligent life is common in the universe, we have not yet detected any evidence of it. Given the age of the universe and the vast number of stars and planets, it seems that many civilizations should have arisen long before humanity appeared. Some of these should have developed interstellar travel and colonized large portions of the galaxy. Yet we see no signs of such civilizations, no radio signals clearly indicating intelligent origin, no evidence of stellar engineering or galactic colonization. Where is everybody? Various solutions to this paradox have been proposed. Perhaps intelligent life is extremely rare, with the conditions necessary for its emergence occurring only occasionally across the entire observable universe. Perhaps intelligent civilizations typically destroy themselves shortly after developing advanced technology, through warfare, environmental destruction, or other means. Perhaps advanced civilizations deliberately avoid contact with less developed ones, following some form of cosmic non-interference directive. Perhaps we are simply not looking in the right way or at the right wavelengths, or with sufficient sensitivity to detect the signals that exist. The question remains open, one of the great mysteries of our age. The continuing search for extraterrestrial intelligence represents an optimistic faith that we are not alone in the universe, that consciousness and intelligence are not unique accidents but general features of cosmic evolution. Whether this faith is justified remains to be seen. Meanwhile, we continue to study the stars, to search for planets in habitable zones around other suns, to listen for signals that might indicate the presence of technological civilizations. The mythology surrounding Pegasus speaks to the human desire for connection with the divine, for transcendence of mortal limitation. In a universe that appears indifferent to human concerns, we seek meaning and purpose, ways to connect ourselves to something greater than our individual lives. Religion, philosophy, art, and science all represent different approaches to this fundamental human need. The stories we tell about the stars, whether ancient myths or modern scientific narratives, serve this same function of providing meaning and context for human existence. The winged horse flying upward toward heaven can be understood as a symbol of the human spirit's aspiration toward understanding and transcendence. We may not literally be able to fly to Olympus to join the gods, but we can expand our understanding, can reach toward knowledge and wisdom, can attempt to comprehend the fundamental nature of reality. This intellectual and spiritual quest, pursued by philosophers, scientists, mystics, and thinkers throughout history, represents a human journey as heroic in its way as any mythological adventure. The tools of modern astronomy allow us to explore the universe in ways ancient peoples could never have imagined. Telescopes on Earth and in space observe across the electromagnetic spectrum, from radio waves to gamma rays. Space probes have visited every planet in our solar system and several dwarf planets and moons. Rovers explore the surface of Mars, drilling into rocks and analyzing their composition, searching for signs of past or present life. The James Webb Space Telescope, launched in late 2021, peers deeper into space and further back in time than any previous instrument, observing galaxies that formed when the universe was only a few 100 million years old. These observations reveal a universe of almost unimaginable scale and complexity. The observable universe contains at least 2 trillion galaxies, each with tens or hundreds of billions of stars. Most of these stars likely have planetary systems. The total number of planets in the observable universe is a number too large to meaningfully comprehend. Among all these worlds, the variety of conditions, environments, and possibilities must be staggering. Rocky planets and gas giants, icy moons and molten surfaces, worlds in tidally locked orbits where one side always faces their star and the other remains in eternal darkness, planets orbiting binary or multiple star systems, rogue planets drifting through interstellar space untethered to any star. The diversity of conditions across the universe suggests that if life has emerged elsewhere, it might take forms radically different from anything we know on Earth. Life here is based on carbon chemistry, uses liquid water as a solvent, and derives energy ultimately from sunlight through photosynthesis or from chemical reactions. But perhaps life elsewhere uses different chemistry, different solvents, different energy sources. Perhaps there are forms of life so alien to our experience that we would have difficulty recognizing them as living at all. These speculations remind us how much we still do not know, how many mysteries remain despite the tremendous advances in scientific understanding achieved over the past few centuries. The universe continues to surprise us, revealing phenomena and structures that challenge our theories and force us to expand our conceptual frameworks. Black holes, dark matter, dark energy, quantum entanglement, the accelerating expansion of space, all of these represent aspects of reality that seem strange and counterintuitive from the perspective of everyday human experience. The Great Square of Pegasus, visible on any clear autumn evening, serves as a portal into these cosmic mysteries. Those four bright stars forming their distinctive pattern are each unique worlds unto themselves, with their own properties, histories, and ultimate fates. They appear to us as simple points of light, but detailed study reveals the complexity underlying that apparent simplicity. Markab, the blue-white subgiant, has a faint companion star orbiting it, detected through careful measurement of its motion. Scheat, the red giant, has expanded to enormous size as it nears the end of its life, its outer layers so tenuous that they barely qualify as matter at all by terrestrial standards. The space between the stars, once thought to be empty void, is now known to contain gas, dust, plasma, magnetic fields, cosmic rays, and neutrinos. This interstellar medium is the material from which new stars form and into which dying stars return their processed elements. The cycle of stellar birth, life, and death continuously enriches the chemical composition of galaxies, creating the heavy elements necessary for planets and life. The early universe contained only hydrogen and helium, but billions of years of stellar nucleosynthesis have produced all the other elements in the periodic table. Every atom of carbon in your body, every atom of oxygen you breathe, every atom of iron in your blood was created in the core of a star or in the explosion of a supernova. The nitrogen in your DNA, the calcium in your bones, the phosphorus in your cells, all were forged in stellar furnaces and scattered into space when those stars died. We are not merely in the universe, we are of the universe, composed of the same materials, governed by the same laws, participating in the same grand evolutionary process that has unfolded over cosmic time. This realization provides a scientific basis for the ancient intuition of connection between humanity and the cosmos. We are not separate from nature, but deeply embedded within it. The boundary between ourselves and the rest of the universe is more permeable and less absolute than everyday experience suggests. The atoms that currently compose our bodies were not always part of us and will not remain so indefinitely. We are temporary patterns of organization, complex structures that maintain themselves for a time by processing energy and materials, then dissolve back into the environment from which we emerged. This perspective can be disturbing, seeming to reduce human significance to mere temporary configurations of matter. Yet it can also be liberating and even comforting. We participate in something much larger and longer-lasting than our individual lives. The atoms that briefly compose us have existed for billions of years and will continue to exist for billions more, taking part in countless other structures and processes. We are part of an ongoing cosmic story that extends from the Big Bang into an unimaginably distant future. The future evolution of the universe, as predicted by current cosmological models, extends across timescales that dwarf even the already vast age of the cosmos to date. The Sun will continue shining for approximately another 5 billion years before exhausting its hydrogen fuel and beginning its transformation into a red giant. As it expands, it will likely engulf Mercury and Venus and may reach Earth's orbit, rendering our planet uninhabitable long before that point. If humanity or its descendants still exist, they will need to have migrated to other worlds in other star systems to survive. Stars like those in Pegasus will continue to shine, evolve, and die. Some will become white dwarfs, slowly cooling remnants no longer generating energy through fusion. Others will explode as supernova, briefly outshining entire galaxies before fading away. The most massive stars will collapse into black holes, regions of spacetime where gravity is so strong that not even light can escape. Over trillions of years, all normal star formation will cease as the available gas and dust is exhausted or dispersed. The universe will enter the era of degenerate matter, populated by cooling white dwarfs, neutron stars, and black holes. On even longer timescales, measured in Google years, 10 to the 100th power, even black holes will evaporate through Hawking radiation, a quantum mechanical process that causes them to slowly lose mass. Eventually, the universe may reach a state of maximum entropy, where all energy has been evenly distributed and no further changes are possible, a condition sometimes called heat death. Alternatively, if the acceleration of cosmic expansion continues, eventually all galaxies beyond our local group will be receding faster than light, disappearing beyond the cosmic horizon, leaving only a small island of matter in an otherwise empty and expanding void. These far future scenarios seem bleak from a human perspective, suggesting that everything we create and accomplish is ultimately temporary, that the universe moves inexorably toward a cold, dark, empty state where nothing of significance can occur. Yet this cosmic pessimism may be premature. Our understanding of physics and cosmology continues to evolve, and we may discover phenomena or principles not yet imagined that could alter these predictions. Moreover, the fact that everything is temporary does not negate its meaning in the present. The beauty of a sunset is not diminished by knowing the sun will eventually die. The value of human relationships does not depend on them lasting forever. The mythology of Pegasus, like all great myths, addresses questions of meaning and value that science alone cannot fully answer. Science can tell us what is, can describe the physical properties and evolutionary history of the stars, can predict their future development. But it cannot tell us what we should value, how we should live, what makes a life meaningful. These questions require philosophical and ethical reflection, drawing on wisdom traditions that include but extend beyond scientific knowledge. The story of Bellerophon's pride and fall reminds us that success and achievement, while valuable, do not constitute the whole of human flourishing. The hero who defeated monsters and accomplished impossible tasks ultimately destroyed himself through arrogance and loss of perspective. This suggests that virtue, wisdom, and self-knowledge are as important as heroic accomplishment, perhaps more so. The Greek concept of sophrosyne, usually translated as moderation or sound-mindedness, emphasized the importance of knowing one's limits and maintaining proper proportion in all things. This wisdom remains relevant in our modern context, where technological advancement and economic growth are often pursued without adequate consideration of their costs and consequences. The environmental crises we face, the inequalities that persist within and between societies, the risks posed by nuclear weapons and other dangerous technologies, all reflect a kind of collective hubris, a failure to recognize limits and to consider the long-term consequences of our actions. We have achieved remarkable things, but like Bellerophon, we may be overreaching, attempting to ascend to heights for which we are not prepared. The challenge for contemporary civilization is to harness the benefits of scientific knowledge and technological capability while maintaining the wisdom and ethical reflection necessary to use these tools appropriately. We need the courage and ambition of heroes like Bellerophon and Perseus, but also the self-knowledge and moderation that might have saved Bellerophon from his fall. This balance between aspiration and limitation, between striving for greatness and accepting constraints, remains as difficult to achieve today as it was in ancient Greece. The constellation Pegasus, with its associations of flight and transcendence, can inspire us to reach beyond current limitations, to explore, to discover, to create. The Great Square provides a focal point for contemplating these themes, a visible reminder in the night sky of both human aspiration and the vast cosmos within which that aspiration occurs. When we look at Pegasus, we can remember both the triumphs and the tragedies of the heroes associated with it, drawing lessons from their stories that apply to our own lives and challenges. As autumn deepens toward winter, as the nights grow longer and the air grows cold, the constellation Pegasus moves gradually westward, making room for the brilliant winter constellations that will soon dominate the evening sky. This seasonal progression, repeated year after year, generation after generation, provides a sense of continuity and connection across time. Our ancestors saw these same patterns, told stories about them, used them to organize their understanding of time and space. Our descendants will see them still, though they will bring their own questions, their own interpretations, their own scientific knowledge and mythological imagination to the experience. The stars themselves, those distant suns scattered across vast reaches of space, know nothing of the stories we tell about them. They shine according to the laws of physics, converting hydrogen to helium in their cores, radiating energy into space, evolving through predictable stages determined by their mass and composition. They do not care about human observation or interpretation. Yet they have nevertheless shaped human culture and consciousness profoundly, serving as navigational guides, seasonal markers, objects of religious veneration, sources of artistic inspiration, and subjects of scientific investigation. This relationship between humanity and the stars represents a fundamental aspect of the human condition. We are creatures who need meaning, who find patterns and create stories, who look beyond immediate practical concerns to contemplate larger questions about existence and purpose. The stars, in their beauty and mystery, their constancy and their distance, provide ideal objects for this contemplative impulse. They are close enough to observe and study, yet far enough to remain mysterious. They are regular enough to serve as reliable markers, yet complex enough to reward detailed investigation. The development of astrophysics as a scientific discipline has revealed that stars are not so different from other physical systems, that they obey the same laws of thermodynamics, gravity, and nuclear physics that govern phenomena on Earth. Yet this reduction of stars to physical objects has not eliminated their power to inspire wonder. If anything, understanding the actual nature of stars, the immense energies and processes involved, the vast scales of space and time, enhances rather than diminishes the sense of awe they inspire. A single star like our Sun converts approximately 600 million tons of hydrogen into helium every second, releasing energy equivalent to billions of nuclear bombs in the process. This has been happening continuously for nearly 5 billion years and will continue for another 5 billion years. The energy output is so enormous that even at Earth's distance of 93 million miles, we receive enough solar radiation to power all life on our planet, to drive weather patterns and ocean currents, to maintain temperatures suitable for liquid water. Yet this represents only a tiny fraction of the Sun's total energy output, most of which radiates uselessly into the vastness of space. The stars of Pegasus, each with their own characteristics and life stories, participate in this grand drama of cosmic energy and matter. Markab, Scheat, Algenib, Alpheratz, and the thousands of fainter stars in the constellation invisible to the naked eye, all are individual worlds of fire and light, each following its own evolutionary path. Some will die quietly, gently shedding their outer layers and leaving behind cooling white dwarfs. Others will end spectacularly in supernova explosions that briefly outshine their entire galaxy. A few of the most massive might ultimately collapse into black holes, those enigmatic objects where our current understanding of physics breaks down. Black holes represent one of the strangest predictions of Einstein's general theory of relativity, objects where space-time is curved so extremely that nothing, not even light, can escape once it crosses the event horizon. The mathematics describing black holes leads to disturbing conclusions. That time itself behaves differently near them, that information about what falls into them may be destroyed, that at their centers lies a singularity where matter is compressed to infinite density and our physical theories cease to apply. Whether such singularities actually exist, or whether some new physics prevents their formation remains an open question, one that will likely require a theory of quantum gravity to fully resolve. The contemplation of such extreme phenomena reminds us that the universe contains realms very different from everyday human experience, where the intuitions developed through evolution in terrestrial environments provide little guidance. We must rely on mathematics and careful observation to understand these extreme regimes, accepting conclusions that may seem bizarre or impossible from a common-sense perspective. This willingness to follow evidence and logic wherever they lead, even to counterintuitive conclusions, represents one of the great strengths of the scientific method. Yet science has its limits. There are questions it cannot address, realms of human experience where its methods do not apply. Questions of meaning, value, purpose, beauty, these require different approaches, drawing on philosophy, art, religion, and personal reflection. The constellation Pegasus can be understood scientifically as a collection of stars at various distances and evolutionary stages. It can also be understood mythologically as a symbol of transcendence and divine power. It can be appreciated aesthetically as a beautiful pattern in the night sky. These different ways of understanding do not conflict but complement each other, each providing insights the others cannot. The integration of these different ways of knowing, the ability to appreciate both the scientific and the mythological, both the measurable and the meaningful, represents a mature relationship with the cosmos. We need not choose between Carl Sagan's cosmos of billions upon billions of stars and the ancient Greek cosmos, populated by gods and heroes. We can hold both perspectives simultaneously, recognizing that they address different aspects of our experience and serve different human needs. As we conclude this contemplation of Pegasus, the winged horse and the Great Square, we return to the simple act of looking up at the night sky. Whether you understand the stars as distant suns following physical laws, or as divine markers placed in the heavens by Zeus himself, whether you see the constellation as a random arrangement of unrelated stars, or as the celestial form of a mythological creature, the experience of wonder and awe remains available. That sense of connection to something vast and mysterious, that feeling of participating in a reality much larger than oneself, that recognition of beauty and pattern in the darkness, these experiences are fundamental to human consciousness and essential to human flourishing. The Great Square of Pegasus will rise again tomorrow evening and every evening throughout the autumn, marking the progression of the seasons, connecting us to the rhythms of the cosmos. The stories associated with these stars will continue to be told, adapted and reinterpreted by each generation, carrying forward themes and questions that have occupied human consciousness for millennia. The scientific investigation of these stars will continue, revealing new details, discovering new phenomena, gradually expanding our understanding of stellar evolution and galactic structure. In this convergence of myth and science, of ancient story and modern discovery, of human imagination and natural pattern, we find a rich source of meaning and inspiration. The constellation Pegasus, in all its aspects, invites us to look upward, to contemplate our place in the vast cosmos, to remember both our limitations and our potential. It reminds us that we are creatures of Earth who nevertheless dream of flight, mortal beings who contemplate immortality, finite consciousnesses attempting to comprehend the infinite. As sleep approaches, as the mind quiets and the day's concerns fade, the image of the winged horse soaring across the starry sky can accompany us into rest. We carry with us the stories of heroes and monsters, of pride and humility, of earthly deeds and celestial immortality. We carry the knowledge that those points of light are actually distant suns, each with their own planets and possibilities, participating in the grand cosmic drama of matter and energy unfolding across billions of years. We carry the simple beauty of 4 stars forming a perfect square in the darkness, a pattern recognized by countless generations of humans stretching back into prehistory. In the quiet darkness, with the stars wheeling overhead in their ancient dance, we find ourselves connected to all who have ever looked up and wondered. The shepherds watching their flocks in ancient Greece, the Arab astronomers carefully measuring stellar positions in medieval Baghdad, the Renaissance artists depicting mythological scenes, the astronomers discovering new worlds around distant suns, and the countless ordinary people throughout history who simply paused in their daily activities to look up at the night sky and marvel at its beauty. We are all participants in the same story, temporary manifestations of the universe's evolution toward greater complexity and consciousness. The constellation Pegasus, the winged horse and the Great Square, shines on above us, indifferent to human interpretation yet endlessly inspiring human imagination. Its stars will continue their stellar evolution long after human civilization has passed, long after Earth itself has become uninhabitable, long after our sun has died. Yet in this present moment, they are ours to observe and contemplate, ours to weave into stories and study with telescopes, ours to use as markers for organizing our experience of time and space. In the end, perhaps this is enough. To have lived in a universe where such beauty and mystery exist, to have been conscious beings capable of appreciating and attempting to understand the cosmos. To have participated briefly in the great cosmic story before returning to the matter and energy from which we briefly emerged. The stars of Pegasus shine down on this moment of human existence, witnessing our attempts to find meaning and create understanding, indifferent perhaps but magnificently beautiful, eternal in appearance though ultimately temporary in reality. Distant yet intimate in their influence on human culture and consciousness. As darkness deepens and sleep finally arrives, the Great Square of Pegasus continues its arc across the southern sky, 4 bright stars marking the body of the celestial horse, wings spread wide in eternal flight, forever ascending toward the heavens, forever present in the autumn sky. A bridge between Earth and cosmos, between mortal and divine, between the stories we tell and the reality we inhabit, between the ancient past and the distant future, shining steadily through the night.